Everybody, welcome to the OWASP Day. This is Tony UV. I'm the OWASP Atlanta chapter leader. I'm going to be covering an introductory walkthrough through PASTA, which is a risk-centric threat modeling methodology that was invented by myself and a co-colleague of mine named Marco Marana, also affiliated with OWASP. So without further ado, I'm going to select my screen here. All right, so hopefully you guys are seeing that. This is a talk called Cooking with Pasta, Risk-Centric, Offensive-Minded Threat Modeling Methodology Intro. And really this is intended for those individuals that are going to be, just wanting an intro into threat modeling and, maybe haven't been exposed into a risk-centric approach. So my focus here today is to really kind of walk you through the process for attack simulation and threat analysis. And I only have an hour to do that, but hopefully we'll cover all of the stages today. All right, so first off about me. So in 2015, me and Marco, we basically wrote this book, Risk-Centric Threat Modeling with Wiley Publishing, because of multiple years of being frustrated on being able to convey application security flaws to product owners, developers, upwards in the organization that we worked at. And so we basically, use a lot of our respective experiences in order to come up with this book. I personally have 25 years of ITIS experience. I used to be an engineer, a developer, a network engineer, also a CISO, a risk management professional. And today I run the security firm Versprite out of Atlanta. Feel free to follow me on Twitter for any sort of additional insight that you want in terms of threat modeling and or security. I'm always chatting about security related items as well as LinkedIn. Okay, so today's agenda, we're going to be focusing on number one, the overview of the methodology and then going through each of the stages. It's my intention to try to reach a broad audience of developers, of architects, of security champions, of those that are just simply curious about threat modeling and want to understand about this risk-centric approach, and then go through each of the stages so that you can take something back to hopefully get started in applying PASTA, which is the process for attack simulation and threat analysis in your respective security programs. So one of the things that is centered to PASTA is it's a risk-centric approach. Now, what does this mean? Well, in security, when you're hacking an application, whether it be a mobile application or an actual IoT-based device, you're really trying to convey to a product owner why they should fix some of the flaws that you've identified. And traditionally, companies or application owners are ignorant in terms of what could go wrong. They don't know if there is something wrong already with their application. They might be having an over-reliance on vendors in order to determine if the tools are actually finding the flaws and just relying on that. And at the end of the day, there's some individuals that might be in sheer panic mode and just simply want to fix what has been found. And so the process for attack simulation and threat analysis was really meant to be a true methodology, step by step, where we can inject these contexts, different types of context that we'll go over. Now, one of the things that, so it has 7 stages, PASTA does. Stage 1, we'll cover this in detail, but it has 7 stages, and these stages are meant to be building blocks of one another. So stage 2 will build off of the, efforts of stage 1, etc. And that makes this to be a linear process that allows you to build on top of each prior stage and leverage existing activities that might be present within your particular organization in terms of security testing, whether it be code review, whether it be third-party library analysis, or whether it be static analysis, even threat monitoring for different types of application infrastructure, but we'll get into that. So the first step is really, let's define the objectives. Oftentimes when you do threat modeling, you don't really understand, what does this application do? What does this application do, not just for the user base, but for the business that is trying to maybe monetize this application. Or maybe this application doesn't even have a monetization model. It actually is something that's more back-end for back-end processing for a company. As a security champion or a developer, you really have to understand what is it that's important that I've been asked to do to develop for this application, or to protect it if you're a security champion or security leader. Same thing, I talked about context was going to be really big in PASTA. So, there's the context of what is important. There's also the context of what is my attack surface. Is my attack surface, some third-party frameworks that I might be leveraging, that I might be overly confident in, that I might not be, considering some vulnerabilities or attack vectors that might be affecting my framework. So oftentimes you can't protect what you don't know. And so it's really important to define that attack surface and understand what that technology scope is. So from a context of what am I working with, that's what stage 2 is about. Stage 3 is, how does this all come together? How do the components of the different language bases that I have, compile libraries, third-party libraries, even cloud-related services or SaaS-related service providers that are maybe managing your identity or brokering your identity store. You want to be able to understand what that scope is in stage 2, and you want to be able to see how it all works together in stage 3. Stage 4, 5, and 6 really is more of the security-centric activities that goes into what could go wrong. Stage 4 is understanding what does my application do, and what sort of threats are out there that want to A, steal credit card, B, achieve persistence, C, do extortion, D, maybe just simply do some defacement or some level of goal settings for hacktivism. You want to be able to have greater context for what you are defending based upon the climate of threats that are affecting your defined attack surface, right? In stage 2, and your technology footprint. Sometimes your technology footprint will actually inherently bring in certain types of threats. Also, your data model consumption might also lend to what types of threats that you should be considering. 5 and 6 are definitely a lot more traditional, but the great thing about PASTA is that it creates this wrapper or envelope around traditional activities like vulnerability assessments, like vulnerability analysis and penetration testing, exploit testing, even some degrees of reverse engineering if there's some time to factor it in. But the key identity here is what is vulnerable, and then stage 6 is what is likely to be exploited and in terms of viable attack patterns. And in terms of stage 7, it's simply looking at what all of this previous stages resulted in. What actually worked in terms of an exploit against my attack surface that I defined in stage 2. Now that I've actually successfully exploited something, how big of an impact is it to what I defined as an objective in stage 1? What sort of vulnerabilities were actually leveraged in order to realize some of the threat objectives in stage 4? So as you can see, PASTA really builds on top of the prior steps in the methodology. All right, so moving on forward, we're going to go into just some other key attributes. It's again, risk-centric, contextual. It's aimed at being more attack-minded, thinking like a criminal. Oftentimes when we do threat modeling, we're thinking more defensively, right? What is, this caller talking to this other, endpoint, as, and we start doing our data flow diagrams. And then oftentimes threat modeling might just end with that. And that is not threat modeling, because where is the threat in that? So it's building context of threats. It's building more offensive-minded psyche about how do I attack this application and for what reason, right? If you have more of a criminal mindset, you can basically say, I want to ... I want to extract personal information. I want to extort. I want to deface. I want to do some level of hacktivism. I want to do some malicious file upload for whatever reason. I want to achieve persistence. I want to do cryptojacking. So you want to be able to think, what are the goals that might be inherent to your industry, to the technology stack that you're using? The process itself, the value is, you have a collaborative approach to doing threat modeling for once. Threat modeling in most activities is usually a security champion and maybe a couple of developers and an architect, and that's it. But PASTA really incorporates other people to the table to have the discussion. What about the infrastructure engineers that are actually provisioning your environment in the cloud, or maybe on-prem? What about the network engineers that are actually governing ingress, egress access for your application? So obviously we all know about the cliche of security in depth. And if you forego some of the other components in your attack surface that support your application, you're really not looking at the entirety of what could go wrong from a threat perspective. Okay, so now let's look at some of these supporting activities to PASTA. Again, this is a process, 101 introduction to the process for attack simulation and threat analysis. And as you see this kind of like beehive looking imagery here, what I'm trying to depict here is a lot of different activities that might already exist in an organization. And so if you're in a corporate environment and you're, a Fortune 500 or a mid-cap 1000 or even a startup, you might have certain, cells of this beehive representation here that are being supported by some of your engineering team, some of your developers, maybe outside third parties. And so PASTA serves as a wrapper to say which of these cells is actually being done, and how could I basically take the output of what these groups are doing and have them as inputs into the different stages of PASTA. And we're going to actually explore that. So we begin with stage one, right? Let's begin with really understanding what's happening in stage one. This is a risk-centric approach. And a risk-centric approach means that you have to understand what is risk. And in simple terms, you have to understand what is important, right, for the organization. And if we frame it in the form of objectives, you can have multiple objectives. I look at threat modeling as a list of libraries and matching them together. So look at this slide as like a library of objectives that the application supports. If you're in retail and e-commerce, maybe one of the objectives is resiliency. Maybe one of the objectives is ensuring cardholder compliance. Maybe one of the objectives is data privacy, right? Depending upon where you are in the world, your requirements and some of the implications if you don't manage privacy correctly. Maybe with some of the loyalty applications that you have on your mobile device or on your web application. There's multiple different objectives that are internally driven, externally driven, that are driven sometimes by companies' customers. And so there's an opportunity to basically now incorporate governance. And from a more of a technical realm that is threat modeling, governance really doesn't make its way into those discussions. But with PASTA, it actually has an opportunity to bake it in from the very beginning. Because if you see and understand that you have, for example, some regulatory or privacy-related requirements to, let's say, retention or encryption for data at rest or data in transit, then you can pull in any sort of governance requirements from the very beginning in order to ensure that business objective of ensuring that you have cryptographic controls for data at rest that is sensitive in nature, as an example. So again, this really begins with understanding not the security objectives, but first, what are the business objectives? And yes, the business doesn't want to get fined. The business doesn't want an application that is not resilient. The business doesn't want an application that's going to cough up, credentials or personal information for liability and reputational reasons, right? So understand the business objectives. And then, from there, you can basically have running in the background what is risky, right? And so here's some examples. So reduce financial risk associated with, let's say, malware banking attacks. And a couple of years ago, malware specific to banks was at an all-time high. And the manner in which those were introduced into, let's say, an application environment could have been through, for example, malicious file uploads. So if you see a rising threat and you know that this malware is looking to steal information and that is a business liability, you want to make sure that your use cases for file upload are properly mitigated, in terms of controls. Another example, just to kind of keep moving on, is related to ensuring confidentiality of client data. Let's say you're a law firm, and let's say you're a development company that develops legal software. Obviously, confidentiality, client attorney privilege is at the backbone of that industry and should be at the backbone of any platform that is digitizing legal documents, especially that are sensitive in nature. So cryptographic means to store the data, to transmit the data, to secure the data, governing access control models inherently should be some technical objectives that support the business objectives. Okay, so that was just a light touch on stage one. There's a lot more to each stage, but because of the shortness of time, I really want to just make sure I comprehensively cover the full methodology that is PASTA. We're going to hit stage two, which is really trying to understand your attack surface. You have to know what you are protecting. In many instances, we as professionals in application security, product security, we don't properly scope, we underscope. We focus just on the application domain, and we assume that other threat modeling conversations are actually happening at the infrastructure level in the cloud, or maybe at the device level. So you really have to understand, it's okay that you might have a smaller threat modeling exercise for just your part of the application. Let's say you're just focusing on the mobile application. You can do a threat model just on your mobile application and the mobile API endpoint. But you do want to understand that you might have dependencies that might relate to extraneous APIs, other web applications, obviously the underlying network infrastructure, virtual systems, even DNS, right? Even DNS. All of these things, if we take it back to stage one, could be the undermining vulnerability, flaw, misconfiguration, whatever you want to call it, that could actually undermine the application, the reputation of the application, and quite honestly, your reputation as a security professional charged with doing some level of security championing via threat modeling. All right, so again, I've said it a couple of times now, you can't protect what you don't know exists. You can't just simply have an, oh, well, I didn't know that was there. And so there is a couple of different things to consider when defining an attack surface. Our goal in this stage is to, what am I running, whether it be things that I've created as a developer, things that I maintain as an engineer, things that I may maintain in the infrastructure, but as well as what sort of dependencies I might have with third-party services. How does my Kubernetes, if I'm using Kubernetes for orchestration for my environments, running different services that have been Dockerized, I need to understand what the configuration is. I can't just simply focus on my API calls, my application calls, and yes, I might have defined the trust models around that. I may have enumerated all the protocols, and the data flows. But if I do have an infrastructure flaw, in terms of my configuration that my application resides on, then I'm not calling my application to be thoroughly vetted from a threat model perspective. So we have to be very comprehensive and understand, what the attack surface is. And this also includes maybe some services that are internal, external, that are responsible for, identity management, federation, whatever the case may be, even operating system settings. If you're going towards more of a traditional on-prem environment, physical system OS that might be housing an application, all those considerations need to be considered. And of course, last but not least, your actual application and software. All right, so with technology enumeration, you might be asking, well, Tony, you're chefing up some pasta over here in the kitchen. What are some ways that we can enumerate and find out what we're running? And so here's some quick examples. Number one, if you're dealing with like web-enabled web-related portal applications, if there's a dashboard, if there's some sort of human interface, you can basically try to run something like built with API. It really does a good job of trying to see what you're running at a very high level, but things that might be that you may not have known in terms of like JavaScript frameworks, widgets, any sort of third-party integration. So very useful there. From a overall application environment standpoint, two great tools is a traditional one and a new one. Nmap, classic, fingerprinting, OS detection, service protocol enumeration, all those things serve as attack vectors, right? for an application. And then Rumble is another great one that runs extremely fast. You can run it for an application environment, both in the cloud and on-prem, and it does a great job of finding out what you're running quickly. Spidering has a great use case in terms of finding out what web pages that you might be having on your site that you may not have known that actually has code. Maybe it has some iframes in there with some embedded, code that's legacy from another site, right? You want to be able to know, again, what is your technology footprint? There's a lot of other lists of things there. I don't want to belabor the topic because I'm already 20 minutes into the presentation here, but everything from proxying, using proxies, PCAP captures, requirements documents that came in from business analysts or project managers that specified these are the internal things that we need to run. Reverse engineering tools, also process memory mapping tools. If you're dealing with more like SCADA type of environments and you want, or like more hardware based, environments, then maybe you can run some process mappers like VMmap. And then last but not least, a tabletop discussion. There's nothing beats simply getting together with the engineering team, the cloud team, developers, architects, and just kind of hashing out and say, hey, what are you working with? What are you supporting for this environment? And then that'll be helpful to align what is the technology landscape. Step 3 is application decomposition. So we built the context of like what is important for the application. We built the context of like, what are we running? Now we are building the context of like, how does it all talk to one another? And this phase, one of the key outputs is trying to understand, do I have implicit trust models, which is always a problem. It doesn't matter if you're, an IoT device talking to the cloud, or if you're basically an embedded device that is talking to maybe an automobile component. You might have an implicit trust model that might be a good conduit for exploitation. So knowing how all the components, again, the components from stage 2 are actually talking to one another is really important. This particular data flow diagramming is produced by Threat Dragon, an OWASP project. So you may want to check out Threat Dragon to see how you can produce data flow diagrams. Stage 3 of PASTA is where you would produce your data flow diagrams, work with architecture, understand what are the calls and the integrations of all those things that you discovered in stage 2 and see how they interrelate in stage 3. Okay, so quick retail example, and we're going to go into some DFD etiquette really quick. So point of sale system. We've all used different point of sale systems, maybe from a consumer standpoint, but let's say you're in the business of developing point of sale software. If we're going to basically do some data flow diagramming, and here's a quick retail example, you want to be able to, label your different flows with action verbs. You want to be able to kind of show like what sort of actions are happening between processes, between API endpoints, between, trust boundaries or trust zones within an application. Traditionally, some of the symbols that have been used over time, some of these aren't used anymore. There's different software. There's a software that's called Threat Modeler. It's a commercial software. It actually uses different types of like symbols and representations, much like you would see in, like, for example, Concept Draw, if you're familiar with that, or Visio. And they have other types of like iconic figures to kind of represent, data sources or callers or different actors that are in your data flow diagram. But if you're going to go old school, the traditional things, like, for example, the parallel bars typically has resembled a data source, maybe a data store, a file system, non-relational database. Obviously, you have your actors. Typically, you have some sort of like asset component that's represented with a rectangle. And then you have your requests and your responses. Oftentimes, when I see a DFD, I see the requests, I don't see the response. I don't see the response going back. It's helpful to know, to be depicted in a DFD that there is a response and if there's anything that is changing. Now, one thing that we do know with data flow diagramming that is changing is the information that's coming back. And that information that is coming back may actually be information that might be, used by an attacker. Another thing too is sometimes the response, especially over web, if you have non-stringent HTTP TLS requirements, where you're not strictly defining that HTTPS should be used, your response back to get an image or something else, or maybe a script, might be coming back over an unencrypted medium. So it's important to not just understand the request, but also the response is coming back. So some quick do's and don'ts. Some quick guidelines and also some tool recommendations. But basically overall, when you have, obviously you have in an application, you have things that run as a process, things that might be event driven, things that might be scheduled, but there's generally a process or a binary that gets triggered to basically make a call. And so typically you can have those types of entities within a data flow diagram talking to one another, but typically you don't have like two data stores talking to one another, automagically. You definitely have typically like a broker or a process doing some level of interaction between two static data stores. So it's just something to consider when you're doing your own homegrown DFDs as part of threat modeling. And please, again, remember that the DFD alone is not threat modeling, because a data flow diagram shows the flow of data between callers across trust boundaries, but it has no depiction of threats. There is no model of threats. So it doesn't really do anything to illustrate to a developer, to an engineer, what should I be worried about, which is really what they're after. All right, let's go into stage 4. Speaking of threats, very good segue, is really trying to understand the threat context. Earlier on, I said that PASTA is really about bringing the context into threat modeling, and threat context has sorely been missing. So it's trying to look at, we don't want to fear monger our audiences, whether they're developers or whether they're, product owners. We want to have credible evidence-based threats to build on. So first off, this is a, pasta is a play on actual food, right? With the Italian pasta. It is an acronym for the process for attack simulation and threat analysis. So you can't have pasta with some weak sauce. You have to have some really good evidence-based sauce in terms of threat analytics. Stride is a mnemonic that has been used and recommended by many of my peers in threat modeling, and it's continuously recommended, and I don't know why. I do know why. The rhetoric is that it's simple. It's simple to implement. It's 6 buckets of spoofing, tampering, elevation of privilege, denial of service, information disclosure, repudiation, and it's static. So Stride 5 years ago, Stride 5 years from now, it doesn't make sense to have static threats. Threats, especially even across industries. What's affecting fintech is not going to be affecting the utility sector. What's affecting e-commerce may not be affecting manufacturing, right? So you have some inherent threats that are industry focused, and it doesn't make sense to have a static threat list for all industries that is static even over time. So it doesn't make any sort of like rational sense, and that's for you, for all of you that are listening, to really understand that build your own threat library. Build your own threat library, and there's multiple different ways that you can do that. We're going to get into that very shortly. So first off, there's two good ways. One is to listen to what everyone else is saying in terms of intel, right? You want to be able to, if you're a threat modeler, if you're the role of who would be doing this would be the security champion. Understand what is inherent to your industry. Understand the threat intel that is maybe providing an insight into attack behavior right now against your industry, your technology footprint based upon your technology selection defined in stage 2. What about your data type, your data model, your data consumption model, right? What sort of threats are more pervasive based upon how you're consuming data? All of these things you can get from different trends, advisories, if you do enough in proper subscription to the right channels. And I understand there's a lot of noise there, but even if you are able to build a threat library that consists of 4 or 5, but that are specific to your application within your industry, for your data model, for your deployment model, that's still going to be way better than a static list mnemonic like Stride. So the other aspect, so beyond listening to what advisories might be out there, is what your application infrastructure is telling your security operations center, right? Or is telling your security incident event monitoring platforms. your application environment is an ecosystem, and there's things that are being requested legitimately and that are being requested illegitimately. And your logs are capturing a lot of this information. It's the capability of different types of solutions to be able to harvest this information and for the security analysts in those functions to be able to say, hey, for your applications, these are some of the types of behaviors, abusive behaviors that we're seeing. We're seeing some session hijacking attempts. We're seeing some brute force attacks. We're seeing some denial of service attacks, right? We're seeing some malicious file uploads. So these sort of things are logged in the applications logs, and they're also logged at different system logs and network logs. And that, combined with threat intel, can provide for more context in terms of what to factor into your threat model. So quick do's and don'ts: build your own threat intel sources, know where your threat intel sources are coming from, maybe subscribe to some different ISACs that are out there, FS ISAC, ITS ISAC, there's a retail ISAC, there's a utility sector ISAC, and see how the threat intel jives with your technology footprint defined in stage 2 and how it's all flowing together as defined by the application decomposition stage in stage 3. Don't use one source of data. Don't use your competitor's threat analysis. Your competitor's threat model may not be your threat model for an array of reasons that relates to, reputation. Maybe it relates to geopolitical associations, to things that might lend to hacktivism. There's a whole different level of attributes that a competitive product for another competitor within the same industry doesn't really lend to you having the same exact threat model. So make sure that you build your own. Just like some homemade pasta, don't just get the store shelf stuff. All right. Just for some more kind of visualization and trying to rethink, how to leverage threat intel is, in a threat model, you want to be able to understand what are my targeted attacks that are targeting me, my application, my company for whatever reason. What are opportunistic attacks, right? And there's always, every company is going to have, opportunistic attacks or maybe industry-related threats. So you need to factor these things and map them to your attack surface. I already mentioned this a little bit. It's kind of belaboring the point, but I wanted to just reemphasize, you have an opportunity to align your threat consumption with your attack surface in stage 2, your industry that supports your application, and then context of what are the impacts of these threats that as you define a threat library, what is the impact to my application from what I've defined in stage 1? And then we're going to get to the, what are these threats and how would they be materialized from a vulnerability exploit perspective? So final thing on Stride is dump it, right? Dump Stride, build your own threat library, use something like STIX. And if we take a look at, just STIX here, and this is kind of just a little sliver, a little prosciutto, if you will, slice to basically get a glimpse of the richness that is available in the STIX frameworks to really create your own threat library, supersede Stride, and have something that's tailored to your application based upon, threat actors that are evidence supported, threat objectives that maybe you weren't considering. And so these are things that are really important to factor in so that you can build your own threat library. Okay, vulnerability analysis and weakness analysis is really where we start to map, what weaknesses will give way to realizing threats. Before we dive in, oftentimes in security, you hear attacks and threats used as in the same terminology. So oftentimes in conversation, I would say, what threat library have you built? And I get responses that says, well, I'm using the ATT attack framework, from MITRE, which is a great framework. But it's, again, no one's doing their homework. Everyone wants to be able to say, let me just get this off the shelf and run with it. This is my threat library. But those are attack patterns, just like KPEC. And then you can build great attack libraries with those things, but you really want to be able to map your threats to what are the vulnerabilities that are going to lead to those threats and what are the attacks that are going to make those viable. So the activities in PASTA specifically is to, begin to think about what are the vulnerabilities that I know about my application that support the threat goals. If my threat goal is to steal intellectual property, maybe one of my things is to really trying to part of that intellectual property might be stealing the client database that's associated with my SaaS product, because I have a nation state that is interested in knowing what customers are actually using this product that they're trying to replicate in their respective area. So having building the mapping the threat objective of like steal client database with maybe correlating the vulnerabilities with the infrastructure that supports that database or database related vulnerabilities is really where we start to have now more of the intra-mappings between vulnerability analysis and threat analysis. So the key point here, obviously, with stage 5 of PASTA is to identify what is wrong. What is wrong with the application in terms of not just vulnerabilities that might be in my code base through static analysis, but also what is wrong with my design? What's wrong with my a trust model that I may have discovered in step 3, in stage 3, where maybe I saw that there have been some implicit trust models between one actor to a data source in my application call. So a lot of things factor into the vulnerability bucket. It can come from prior manual security testing and some flaws or weaknesses that were identified there. It could, vulnerabilities or weaknesses in architecture could stem from going through that data flow diagramming through stage 3. Obviously using different types of vulnerability scanners at different levels in order to understand what part of my application environment is actually vulnerable that would give way to realizing some of the threats in stage 4. Some good tool recommendations, just, it's always good to make some tool recommendations. Obviously your traditional vuln scanners that are out there, Nessus, Qualys, etc., EdgeScan. Node Security Project has a great project where it actually basically lists out and ties to the NIST National Vulnerability Database to see what sort of associated vulnerabilities might be affecting your Node.js implementation. Retire.js and Sync.js. Retire.js is really cool because it looks at what sort of JavaScript libraries and functions you actually may need to deprecate because they're vulnerable to different types of vulnerabilities that have been found. The OWASP dependency check is a great project in order to find what sort of third-party dependencies that you might be using that might be vulnerable based upon the tool's dependency checker. Black Duck, Gymnasium, SourceClear. SourceClear was a company developed by one of the founders of OWASP, Mark Herfey, and also does a great job in trying to find flaws within your application environment. The tools list is endless. It's really the mindset. This is a talk about following a process and sewing together tools, practices, in terms of vuln management, vuln assessment, static analysis, dynamic analysis, baking in all those things and saying, of all of the noise that I'm seeing in vulnerability analysis, which are the ones that are material to the threats in my threat library, right? The whole point with PASTA is let's focus on the things that are most risky in terms of impact to the business, again, based upon stage 1. All right. I talked a lot about this already, so we're going to move forward just for the sake of time. But really the key thing here is that you have an opportunity, either maybe if you're a developer and you're trying to follow this process, maybe you tap on the shoulder of your individual in your organization or outside your organization and say, give me a list of validated, non-false positive vulnerabilities that would realize these threats. So let's walk through this example. Let's say that you are a software development company and you don't have a security team and you rely on a third party to do pen testing. And so you basically say, guys, outside group, we developed this threat library. I want you to basically find all the things that you found in your last pen test or maybe your managed service vulnerability assessment service that they do for you and say, hey, give me all the true positives that match these threats. And so let them do the hard work, get the ROI in that relationship, have them basically then enumerate what becomes then a vulnerability library. We have a threat library, we have a vulnerability library, right? So we start to build out these libraries, and then that's what's going to basically lead to some of the trees that we're going to build in the next stage. One of the opportunities that you have with PASTA, and there's not enough time to really talk about the interrelationships of different frameworks that are out there, but you take ASVS, the Application Security Verification Standard, you take the OWASP TEP 10 if you like, but you have an opportunity to look at domains that might be of concern, right? If you are managing an application or you're developing an application and it is an application where there's a lot of sensitive information in there, and you want to ensure proper authentication and proper authorization models, then out of the gate you may have identified that authorization and authentication were high impact areas from stage 1 in PASTA. Now under vulnerability management, you have an opportunity to see under ASVS and OWASP Top 10 what sort of like activities, what sort of risk, what sort of like standards in those respective areas need to be checked almost systematically. So you're contextualizing everything from the prior levels, contextualizing what's important to do from stage 1, contextualizing what you're caring about from stage 4 in threat analysis, but everything builds upon the prior step. Now, you might be wondering, well, what are some good inputs and outputs for this specific stage of vulnerability analysis? And inputs might be, obviously, you want to bring in your technology enumeration that you found. You found your attack surface in stage 2. You want to scan it and make sure there's nothing vulnerable there, right? So stage 2 is a great input for stage 5 because it says, this is what my attack surface is. And I want to know what here is vulnerable. Not just what's vulnerable, but what's vulnerable that supports the threats defined in my threat library. That is very important because otherwise it just becomes big lists that makes threat modeling to be very, very time consuming. And that's not what risk-centric threat modeling is about. It's about focusing on the things that are higher impact and threat that have a higher risk level for the application. So same thing, I had, I think, a mobile application example here, threat intelligence for mobile application. Really, that's just meant to be put in here as an example for mobile applications. If you're developing mobile applications, like what are mobile malware, big problem. And you might have use cases where, okay, well, how is mobile malware actually happening? Is it because it's trusting other types of applications of a certain type that authorization is needed by the user? And so that might affect your use cases that you have in your mobile client application, as an example. So inputs are going to be threat intel, obviously context of what is important business impact. But outputs from this phase are going to be like, all right, let me basically, produce my static analysis reports, vuln reports, web application dash reports, etc. So that, now I want to be able to create a vulnerability library of things that I'm concerned about, that are real, that are vetted, that support, and that could make the threat objectives to be actually true. So we're going to get to the good stuff. This is the attack modeling phase. This is where we start to think more like a criminal. Now we want to prove that the things that we found to be vulnerable are actually viable. And proving that is so centered to risk-centric threat modeling because it's not a risk if it's not viable, right? Now, it puts a lot of emphasis on testing for viability, but you can blueprint a good model for attack by using attack trees. And the parent node of these attack trees are typically something that, begins with like a threat objective. Like maybe you want to, as a threat actor, you want to compromise credit card information. And maybe your target asset as part of that is you want to focus on the browser or the client application that might be interacting between the user or the human actor and the actual the credit card information itself, right? So, you under the underlying node is usually the asset or target. And then from there on down, you could have one layer of attacks. You could have 2 layers of attacks. This is where you pull in KPEG. This is where you pull in attack, right? This is, and you can rope in those types of attack patterns and say, how could I realize man in the middle attack, at the browser level? What type of attack pattern is, or exploit do I need to look up in my attack framework library or my KPEG library to see that I want to test specifically for this? Ultimately, what you want to get to, this becomes a blueprint for exploitation. This becomes a blueprint for what you want to attack on your application or your application component. And your attack tree can be large, medium, or small, right? If you're doing iterative development and you're just building out one component of a story in your software development lifecycle, you may have one target asset or use case that you want to map out. What are the attack patterns or abuse cases that you want to exercise? Attack modeling, stage 6 is where that exercising actually happens. So, I talked about you could have, this is like what I consider to be a branch. Your trees can be small, they can be, they can be big. And, the good thing about attack trees is that they can be focused on just one aspect or facet of a component of your application. Here we're looking at a attacker trying to impersonate another user, and the attack is trying to see what ways, what means, what other attack patterns would allow for this threat from to take place. And so you might have things around spoofing in terms of trying to spoof the authentication token. Let's say that you have a dynamic token that is created because of some homemade tokenization service that you might be building or running, but let's say that it's not very good and it's predictable mathematically. And so, those are attack patterns that you want to say, well, how likely is it for me to mathematically guess, a dynamic token that's created based upon my knowledge of what the algorithm appears to be as an attacker. And so they want to test that viability so that they can maybe guess a legitimate token and render it back to the application. The point here is that we start to map threats to attacks. And what's missing here is definitely the vulnerability. We can do threats to vulnerabilities, and then what attack patterns could actually exploit that vulnerability so that we can get to the viability question that we're needing to answer. Here's another example, point of sale system. I wish I could kind of scope in here a little bit. I think I'm going to try to use this guy right here. Okay. So, the idea here is that, again, it's all in layers, and you can build different. This is another rendering of an attack tree. Here we have threat motive, threat agent, target entity, basically your application component or target entity, and then the attack patterns. Here's the attack vector, the attack pattern. But, these trees are very helpful because, again, they provide a blueprint for, trying to begin with an entry from your threat library, steal credit card data. And then you basically kind of understand, this crime syndicate node is meant to represent the threat intel that you found in stage 4. This vendor software development component or this vendor logical access, looks like these are vendor dependencies within the application model that serves as, a target asset. The illicit software repo access is meant to do a supply chain attack right here. So this is the attack vector. This one right here, if we have a vendor and I'm a criminal that's trying to basically, being supported by a crime syndicate, maybe your application is pretty resilient from the front door, but I maybe do enough fingerprinting of your application in order to sniff out that you're using a vendor as part of your overall application environment. So maybe I want to taint the software repo of that vendor so that I can backdoor into your application. So this sort of like attack conceptualizing is very, very helpful, very, very important. You're not going to get there with Stride. You're going to get there by building your own threat library, mapping the vulnerabilities that realize those threats, and then mapping the attack patterns that says, is this vulnerability viable? Let me just dip out of here. All right, next slide. All right, so here's yet another example. I wanted to provide a lot of examples on the attack tree stuff, and the main thing here is that a blueprint for attack. PASTA is the process for attack simulation and threat analysis. Think like a criminal. How do we get there? Let's not waste time as white hats and run like no shade on Metasploit, but just simply run a Nessus scan and run Metasploit and say, hey, I'm a hacker. No, that's definitely not how a real criminal is going to operate. They're going to say, first, what do I want, right? Do I want credit card data? Do I want to do malvertising, right? To basically introduce, malicious ads through your platform if it consumes ads. They're going to think that way. So the attack tree provides a blueprint. So maybe you are focused on, as a target, the browser or the client side. So test the possibility for browser or client side attacks. Maybe you want to look at, SQL injection as a viable attack pattern that is really aimed at the target of the web application. So then great, then maybe come up with a good attack library of numeric SQL injection or logical based SQL injection in order to basically see the viability. You guys get the example. The attack trees, whether you do it internally in your organization or externally, you have the opportunity to build out a blueprint for attack. Excuse me. All right, we got 10 minutes left. We're in the final stretch, stage 7, residual risk analysis. At the end of the day, it's about reducing risk. Application teams are being paid by somebody up top. There's a rationale for that application. There's a reason for that application. There's valuable information around that application, context of what's important. Let's focus on building countermeasures that mitigate the threats that are important. So in this stage, we want to reintroduce some of the prior stages of stage 1, what's important, what do I care, what are the objectives of the application. Stage 2, what are the components that I'm working with that are the focus of my countermeasures that I need to apply. Stage 3, how do they all work together? Stage 4, what is my threat intel telling me? This factors into the threat variable in my risk formula. Excuse me. So residual risk formulas, and risk formulas are as a dime a dozen. Residual risk, let's just jump to the good stuff right here. This 4th bullet point here, residual risk should be a reflection of the probability of threat occurrence, right? And that's usually in stage 6. Like I have a threat defined in stage 4, and in stage 6, I test the viability of attacks that support that threat. It's not just testing any attacks. It's testing attacks that realize those threats. So it's all contextual. Same thing for probability of vulnerability. What is the probability that vulnerability might get discovered? Not all vulnerabilities are equal. I mean, there might be some, an embedded component within a highly protected, hardware device that is deployed. The deployment model is internal only into a back office of, of an environment, a customer that bought that product. The probability of the vulnerability discovered is something that also needs to be considered, right? And so when you look at probability, that's going to say, well, do I care about the vulnerability because I see that the vulnerability details from the researcher says that it depends on ABC. It builds off of these other prerequisites. Same thing goes with threat. If it is an internal embedded device that is running on a hardware device that is internal to a private network, then I have to basically evaluate what does my threat intel say about insider threat. Are there viable, realistic, evidence-supported threat scenarios that are supported by evidence? And last but not least, impact and then countermeasure. What is the impact of a vulnerability existing? It gets exploited. It's demonstrated by stage levels 6 in PASTA, attack modeling. So prove an exploit, it works, but what's the impact? And then what countermeasures do I have to either tighten down my network, my cloud infrastructure, my application through, introducing better code that I can basically now have a residual risk of understanding. This residual risk makes remediation, countermeasure development to be topical to the most important high impact risks that the application is facing based upon evidence of threats, based upon the inherent impact level, based upon vulnerabilities that have been mapped and proven through exploitation through stage 6. At the end of the day, this is what we want to get to. We know that when we do security analysis of an application, we identify things that could go wrong in red and things that ultimately at the end of threat modeling, the value that developers and engineers get is that they're going to get prescriptive guidance on what to mitigate that is relevant to, again, the most impactful scenarios. If we can prove the viability of attack to developers in stage 6 and demonstrate the business impact that is inherent in stage 1, that affects their technology assets as defined in stage 2, then we can basically have a residual risk analysis that says these are the things prioritized that you need to fix. When you're a CISO, and I've been a CISO several times over, one of the things that is hard is to do risk prioritization, knowing what to fix first. And the developers have the same problem. They get a whole litany of things to fix, usually from an output of scanners. They need the guidance. They need the threat analysis. They need the risk prioritization. And that's what really PASTA is about. So this slide is really, really tiny, but just really quick, we're towards the tail end of the presentation here. This is a racing model for PASTA. What it does is it says, hey, let's break down PASTA. Who's involved? What are the players? Here are all the stages. Here are every stage in PASTA has activities. And so you have, excuse me, you have different roles that have a RACI responsibility. RACI means responsible, accountable, consulted, or informed. So you have management, you have a project management office potentially, you have business analysts, you have architecture, you have dev, you have systems engineers, you have QA, you have security analysts in the SOC, you have vulnerability assessors, you have pen testers, you have risk assessors, compliance people, you have software assurance people, and then there's you, security champion, extraordinaire threat modeler. So this is, a good kind of a representation for what roles should be actually involved in which activities under which stage. Really quick, because I know I only have a couple minutes left. This is also, if you're trying to see where does this fit into the software development lifecycle, depending upon which methodology in terms of SDLC you're using. Most people out there are using Agile these days, but you can make any of this iterative. This representation here basically says that, for example, under the defined objectives stage, you might have management and business analysts to be really producing things like a former risk residual report or a risk profile or a former application assessment that was done on the application to build in that inherent risk. But also importantly is that maybe you have security requirements that are really opportune to be defined in stage 1. And that's why during a traditional SDLC lifecycle, you put in security requirements during the definition stage, right, where you're defining requirements. The threat modeling overall, as represented by this diagram, has an opportunity to go further left of the SDLC than just simply post-deployment. So that's a huge opportunity, and definitely an opportunity with PASTA. Really quick before I finish up here, you guys might be thinking, well, this seems like overarching. There's a lot of steps here. There's a lot of activities. You can actually build your own PASTA. If you're only ready for 1, 3, and 6, do it, right? And the great thing about PASTA is that, like in the book, if you want to check out the book off of Wiley's website or Amazon, it actually has mappings to BSIM, Open SAM recommendations for software assurance maturity modeling. Definitely follow a crawl, walk, run model. Create goals in terms of how you want to adopt this methodology over time. And also define what sort of activities in each stage of that maturation do you want to operate in. This is just simply an artifact related to mapping in BSIM. I'm going to go ahead and zoom in here real quick. But the idea here is that you have PASTA stages, and if you're familiar with the building security and maturity model, this actually came straight for the book. In building security and maturity model, you have different domains or activities that relates to creating standards, that relates to engaging with architecture, performing security reviews, and that way, if you are interested in embellishing PASTA into your threat modeling process, you can actually map it to a maturity model so you can measure and track how you're doing over time. Oops, sorry. We are here at the very end. Listen, everyone, to all the OWASP global community out there, I really appreciate your time. I appreciate the opportunity to bring to you a introductory level of the PASTA risk-centric threat modeling. Please follow me on Twitter, T0NYUV, or follow me on LinkedIn. Definitely, if you want to check out the latest depiction of PASTA, go to Versprite.com, security offerings, AppSec, application threat modeling. Not only does it have all the stages, it also has a lot more detail in kind of a summation model that you can operationalize and take it with you. And on top of that, there's an ebook that you can use as well. Thanks so much, and great to be here.
Thank you very much, Tony, for this presentation. If you have any question, maybe we have one question from someone. Can you speak to some of the tooling incorporate PASTA?
Yeah, so in the past, Threat Modeler was looking into, looking to bake in Pasta. I know that, my company has looked to Arius Risk to see if we can build our own templates in Arius Risk. Arius Risk is another platform that's out there for threat modeling. But right now, I mean, if you're a threat modeling practitioner, most of the threat modeling tools that are out there, like Arius Risk or Threat Modeler, you can actually build and take Pasta as a methodology and say, I want to build in, these requirements as part of my threat model process within the tool. So it's really meant to be a methodology and really meant to be a process that security professionals follow. So you can build it in any tool, but I think more tools are going to be forthcoming. There is a Python threat modeling tool called PYTM. I know some of the members from OWASP, and I know they're actually coming out with their own book. So I'll be looking to see if I can make some templates that are Pasta centric.
Okay, thank you very much, and keep connected with our OWASP YouTube channel. We have another presentation. John will start that. Thank you very much, Tony.
Appreciate it. Thanks. Take care.
Bye.
Bye-bye.
Bye.